Alright, here we have lecture 2.6, which will correspond with section 3.5 from the textbook, and it's here. We'll be looking at transformations of functions. So, transformations are what happens when we add, subtract, multiply, or divide functions by some constant. And the short version is if we add or subtract by a constant, we will shift the graph, either left, right, up, or down. And if we multiply or divide a function, we'll stretch or compress it. And if we, of course, multiply by a negative, we'll reflect. We saw how multiplying by a negative reflected when we studied symmetry at the very beginning of the unit. But we're going to go ahead and open up with shifting. So we'll start with vertical shifting. So if we add by a positive constant, k, then we'll move the graph up k units, and if we subtract, we'll move it down. So that's pretty intuitive. Addition, make it go up. Subtraction, make it go down. Note that we are not adding and subtracting to the x coordinates. We are adding and subtracting to the outputs, i.e. y coordinates. Now, horizontal shifting is where it gets a little bit squirrely. Notice that it's inside the actual function operation. So it's applied directly to the x coordinates, but it is inverted. Addition is actually going to shift the graph to the left. Subtraction is going to shift it to the right. So that's actually maybe the opposite of one might initially think. Right? Because if we've ever played, Super Mario Brothers on the Super Nintendo, we associate, going to the right is moving forward, going to the left is moving back. So you would think addition moves you forward, subtraction moves you back. It's actually inverted. Addition is actually moving you backwards, i.e. to the left. Subtraction is actually moving you forward, i.e. to the right. So let's go ahead and look at some examples here. So here we have function f of x, and it wants us to graph f of x minus 3 plus 2. So if I look at that, f of x minus 3 plus 2, I need to read that means right 3 up 2. So I'm going to take each coordinate and just go right 3 up 2. So I'll start with the leftmost coordinate, go right 1, 2, 3 up 2. Mark it. Take the next coordinate, move it right 1, 2, 3 up 2. And then take the last coordinate, move it right 3, 1, 2, 3 up 2. And we'll go ahead and connect the dots. So as you can see, all we didn't change the image at all. We just moved it to a new location, right 3 and up 2. Now, if we go ahead and look at g at x, we want to go ahead and graph g at x plus 1 minus 4. So that's actually going to be left 1, down 4. And I'll go ahead and start with the rightmost point. We're going to go left 1, down 4. 1, 2, 3, 4. Plot the dot, and then we're going to take the next one, go left 1, down 4. Right there. And then we're going to go ahead and take the next dot, left 1, down 4. And connect the dots. So it kind of lines up. I'll try and sketch it a little bit darker so you can kind of see it. But we just took that image and did left 1 and down 4. Alright, so that is shifting. Let us now talk about reflecting. So we've already talked about reflecting. We discussed reflections when we covered symmetry, which is in the very first lecture of Unit 2. Now, of course, we got reflections over the x-axis, reflections over the y-axis, and reflections over the origin. Now, the origin is the easiest to identify because it's you make both negative. However, it's reflections over the x-axis and y-axis that are easy to confuse. So if I want to reflect over the x-axis, notice the negative is outside. If I want to reflect over the y-axis, the negative is inside. And let's think about it like this. Take this dot. If I want to reflect it vertically, that would be actually over the x-axis. So one thing you're going to notice, all the inside transformations are horizontal transformations. All the outside transformations are vertical transformations. So if I'm reflecting vertically, it's actually the y coordinate that is changing, which is why the negative is on the outside. If If I'm reflecting over the y-axis, that's actually more of a horizontal transformation, which is why we see the negative on the inside. So let's go ahead and look at these examples. Here we got the square root function, and we're going to reference that. So y equals negative root x. Notice that it is negative on the outside, so that means it's going to be a vertical reflection. In other words, it's going to be over the x-axis. So graph is going to look something like that. Notice here we have a negative on the inside, so that's more of a horizontal transformation, which means that if we reflect from left to right, it's actually going to go over the y-axis. Look like that. And then of course this is both. This is origin, so whatever's in quadrant 1 is going to reflect into quadrant 3. And it looks like that. Alright, that's reflections. So let's look at stretching and compressing. So stretching and compressing is done via multiplication and division. And like I mentioned just a minute or two ago, transformations on the outside are vertical in nature. Transformations on the inside are horizontal in nature. And of course the horizontal is inverted. So if I multiply by some positive constant a, it's positive so that we don't confuse this with a reflection. We're just multiplying each y coordinate by a. So if we multiply by a number bigger than 1, the numbers get bigger and thus we stretch. If we multiply by a number between 0 and 1, say we multiply by 1/2, multiply by 1/3, multiply by 1/4, multiply by 0.15, something to that effect, it's actually going to make the y coordinates smaller and thus compress the image. Now remember, the horizontal transformations are all inverted, so in the case when we have b times x, what we're actually doing with each x coordinate of the original function is dividing. Thus, if we divide by something greater than 1, you'll see a compression, because if you divide by 2, divide by 5, divide by 7, divide by any number bigger than 1, you'll get a smaller value. If you divide by something like 0.5, 0.3, 0.2, well, division by such a number will actually cause it to grow. Alright, so let's go ahead and use this knowledge to do 2 quick examples. So let's go ahead and graph 2 times f at x. Now notice it's on the outside, which means it's vertical, which means we're playing with the y coordinate. So we're going to multiply every y coordinate by 2. So the x coordinates don't change, it's the y coordinates we're changing. So looking at the leftmost point is at -1, 2. Well, we're just going to multiply that y coordinate by 2. 2 times 2 is 4. And then in the center we have 0, 0. 0 times 2 is still 0. And then here we have 1, 2. 2 times 2 is again 4. Connect those dots. So as you can see, we have vertically stretched that image. It's still a V type shape, but it's quite different. So that's 2f at x right there. Now let's graph g at 2x. So g at 2x, this is inside, so it's horizontal and it's inverted. So we're not going to multiply. We're not going to be multiplying, we'll actually be dividing. So we'll start with the leftmost point, which is at -2, +2. So when we do -2 divided by 2, we get -1. The y coordinate's not changing. 0 divided by 2 is still 0. And here we have 2, 2. Well, 2 divided by 2 is 1. And connect the dots. So here you can see we got g at 2x. So you can see it's been a horizontal compression. So, as you've seen in the last 3 subsections, transformations do not change the core characteristics of a function. They only shift, reflect, or stretch. So you want to make frequent use of that library of functions sheet that was posted just above this lecture. And if you are graphing transformations, a great strategy is to prioritize the center/start point. So for many functions, the center point is the origin, right? If you're talking about a square function, square root function, cube root function, cube function, absolute value function, all of these are centered or start at the origin. Use that to your advantage. So when we look at number 1, we want to graph this function. Now notice all that addition, multiplication by negative, those are all transformations. So yeah, those will shift, stretch, and reflect, but they don't change the core characteristics. So the core characteristic of this function is the squaring. So go ahead and pull out that library of function sheet. Go ahead and pause right now if you need to. Hit the pause button if necessary. I want you to reference that library of functions sheet. Now, while you're looking at that library of functions sheet, you should see the square function, and it's shaped like a parabola. Okay, well, this is also a square function. It just has some transformations. So we already know what the answer is going to look like. It's still going to be shaped like a parabola. Now, if we're going to be graphing this shape, the center is the most important point. So that's where we're going to kind of strategize. We know for the original parabola, it's centered at 0, 0. So the clever trick here, and this is where you want to listen very closely, you want to ask yourself, okay, what x value would get me back to 0? We're going to try and, reverse the transformation. Well, -3 will. All right, if I punch in -3, you'll get 0. And go ahead and plug that in. You get -3 plus 3 is 0, 0 squared is 0, -0 plus 4 is 4, and there's our center. There's our center. So a little tip here. If you can, use 0 to get back to center. Right. So if I want to get back to the center of this parabola, I need 0. Well, how would I get 0? By plugging in -3. I would get 0 inside. I should say, I guess, 0 inside. So, and then once I have this, I'll just pick one point to the left of the center and one point to the right of the center. So that would be -4 and -2 respectively, and just plug them in. If I plug in -4, I get 5. Or hold on, I get 3 actually. And if I plug in -2, I also get 3. And then it's just a matter of connecting the dots. So I got -3, comma 4. There's my center of the parabola. I got -4, comma 3. There's another point. And there we have -2, comma 3. If we want, we can go ahead and graph another one. We can go as far as -5 and -1. If we plug those in, we'll get 0 respectively. So that's more than enough dots, so we'll just connect the dots and draw the shape. And there's our parabola. Now, you notice the negative sign means it's been reflected. And notice the negative's outside, so it's been reflected vertically. That's why the parabola is opening down. +3 means left 3. +4 means up 4. And that's exactly what we see in the graph. So let's go ahead and look at example number 2 here. We'll start to form a T-chart. And again, look at that library of functions. Figure out what this is going to be shaped like. Well, this is going to be shaped like the cube root function, which looks like that. So we need to find the center of that. The center is the priority. So we can find that center by determining what x value would produce 0. So I want to think, okay, what would make that 0 there? Well, 5 would. So, and then punch in 5 and you'll get 2. And there's the center of our cube root function. I'll just go ahead and pick 1 point left of the center and 1 point right of the center. Plug those in and evaluate. And you'll get, let me see here, so 3, and when you plug in 6, you get 1. And we'll connect the dots. So we got 2, 4, 5, 5, comma 2, that's our center. 4, comma 3, and then 6, comma 1. And there's our graph. All done. So as you can see, note the horizontal transformation with the negative on the x, which, so if we were to write this, we could write it kind of like this. Thus, the minus 5 is bringing it right 5. The negative gives us the horizontal transformation, and the plus 2 moves it up 2. So, just to summarize here, horizontal transformations are seen inside and typically inverted. Vertical transformations are seen outside and pretty straightforward. Addition and subtraction will shift, negatives reflect, multiplication, division, stretch, or compress. So one last example. Let's go ahead and look at this function and read the transformations. Note the negative is on the outside, so it's a vertical reflection. So if I take this dot reflecting it vertically, reflecting it up and down, well, that would be over the x-axis. And it's stretched vertically, because again the multiplication is on the outside. It's shifted blank 3 units, that's on the inside, so minus is actually going to move it to the right. The 5 is plus 5 on the outside, so that's up or down, while positive means it's gone up. And we are done. So there's a quick lecture on transformations. I'll also, I went through this fairly quick, so if you are comfortable with transformations, this may be sufficient for you. If not, I'll also go ahead and throw in a supplemental lecture that I encourage you to watch. Keep up the great work, though, and we're almost done with Unit 2.